this video. This is the configuration and verification of switch interfaces. So first, I just want to apologize. It's been quite a long delay in getting this video out, but nevertheless, and there's quite a lot to cover in this video. So what I'm going to do is this will be a part one, and then we'll have a part two at some point, which will include a practice test. But I potentially might combine some other topics in there. So it's not just a practice test of this, but also of VLANs as well. So but I'll let you know about that in the future. So what we're going to be covering this lesson. So firstly, IEEE auto negotiation theory, auto negotiation configuration, auto MDX, automatic medium dependent interface crossover, automatic medium dependent interface crossover. Quite a mouthful there. Managing switch interface configuration, analyzing switch interface status and statistics. So there's quite a lot to cover, but it should be a fun lesson. So I'm really excited about this, and thank you guys for joining. So 5 parts. Let's get into the first part. So IEEE auto negotiation theory is the first part that we're going to cover. So what is auto negotiation exactly? Well, auto negotiation is the process of switches. Basically, you got a switch, and it's switches connected to each other on each end of a link, and they're making that decision themselves of, hey, just like two adults would, about what of when they want to make an agreement. These switches are making an agreement of what speed and duplex they're going to use. So it's quite an important process. But it's quite cool because this happens automatically. They're deciding what speed and duplex they're going to use, and it's best practice to have it enabled on both ends of a switch, or not use it at all, and just have your speed and duplex settings manually configured the same. That's the best practice from Cisco's recommendation. So there's two circumstances we're going to talk about here when it comes to auto negotiation. One is when you have it enabled on both ends of a link, and this is the easier scenario. This is the easier scenario here, is that it's enabled on both ends of a link. It's enabled on both ends on each switch. The process is much more simpler because both end devices are going to send something called FLP messages. Now, what are FLP messages? FLP messages means fast link pulse messages, and it's basically when a switch it's basically announcing, hey, this I'm switch 001, this is me, this is my speed that I'm using, this is my duplex I'm using, is telling the other switch about itself, is declaring a speed and duplex settings. And once each switch hears from the other, they'll make the decision not to use the fastest speed and the best duplex setting. This is when you have it enabled on both ends of a link. The fastest speed and the best duplex setting. Now, the logic of auto negotiation when it's enabled on both ends is simple. This is just a repeat of what was on the last slide. Fast link pulses. Now, fast link pulses, just a bit more about them. It's the proclamation of the capabilities of that switch. Includes data in the messages, which include bits identifying the Ethernet standard supported and the duplex ability supported. So there are bits in the FLP messages that identify the Ethernet standards that are supported and the duplex ability that are supported by the device. FLPs use out-of-band electrical signaling. Any device that uses auto negotiation supports those out-of-band FLP messages. They support the out-of-band FLP messages. Now, like I said, the recommendation is use auto negotiation both ends on the Ethernet link, or disable on both ends, either one or the other. The other side of the coin is parallel detection. Now, when you don't have auto negotiation on both ends, this is not desirable. But if this is the case, so when you configure on one side, then something happens called parallel detection, and parallel detection is like when you have I'll show you an example of Claire and Louise. Claire and Louise's PCs, but I'll show you an example. But basically what's happening is you're having a case where the switch is now kind of doing a sense check. So if auto negotiation is configured on one side, and in fact this is better than the Claire Louise example I'll show you. You got a switch in New York City, you got a switch in Boston, Massachusetts. Now the switch in New York has auto negotiation enabled. The switch in Boston doesn't. So what happens is the New York switch doesn't receive FLPs from Boston. It doesn't receive any FLPs. So then it has to kind of do this. It has to do this parallel detection process where it's kind of sensing. Okay, I think Boston is using this speed setting. So this is my guess what he's using. And how does it do that? It does that from it does that from analyzing the electrical signals, incoming electrical signals, and then from there it kind of determines, okay, I think it's using this speed setting. And so once it's chosen a speed setting, it will then using a very simple logic. If it's 10 over 100 meg per second, if it thinks it's using 10 over 100 meg per second, it will choose a half duplex setting. If it thinks it's 1 gig per second or more, then it's a full duplex setting. So the switch will make that decision there. Okay, but this process of parallel detection is kind of like you're doing a sense check. The switch, which has auto negotiation enabled, is trying to kind of guess for the other that I think is using the speed setting. I think is using 100 meg per second, and from there half duplex. So in this case, this was the circumstance here, 100 meg per second. It thinks it was using 100 meg per second based on analyzing those incoming electrical signals. It thinks it's using 100 base T, 100 meg per second. Then it assigned a half duplex using that very simple logic: 10 and 100 meg per second, half duplex, 1000 meg per second, 1 gig per second, sorry, or greater, full duplex. Now, okay, so it's done this now using parallel detection. Great. There is a slight problem here. I won't talk about too much for now, but this is a duplex mismatch. You got half duplex on one side, full duplex on the side. This is not something you want to have. It's not something you want. But the link will still, it doesn't result in a failed link. So this is why these kind of problems are harder to detect than your speed mismatch, because the speed mismatch, that will result in a failed link. Duplex mismatches, duplex mismatches don't result in failed links, but they are problematic, so you don't want them. But I won't talk about too much for now. Just to understand that the parallel detection process has happened here, and it's kind of used that parallel detection has now assigned that half duplex and speed setting to the Boston switch. Now, I won't get too much into that those examples now. What we're going to talk about is yeah, please. This is best practice. Auto negotiation both ends of the link enabled, or if you have a strong reason not to do so, fine, but just make sure that both sides have the same speed and duplex settings, same speed and duplex settings assigned, configured. Okay, now many devices have that capability to disable auto negotiation, and this can result in maybe an inexperienced administrator making that poor decision to disable auto negation one side and not on the other, and this can cause you duplex mismatch and late collision problems. So it's definitely a no-no. Right, so let's talk about the configuration of auto negotiation. So when we want to configure auto negotiation, there's two interface subcommands we want to use. So sorry, I've repeated this word twice. Sorry, that's my bad there. And why have the news come on the screen? Sorry. So for the subcommands, we've got two interface subcommands for that auto negotiation: the speed auto and duplex auto. Okay, so you can use speed and duplex and auto duplex for the configuration of auto negotiation. But you got to remember, if you configure them, you're not going to see in the running configuration. You will not see in the running configuration. It doesn't show. It's invisible. If you wanted to verify your speed and duplex settings, you'd use show interfaces status, like in this example here of a London switch. So London switch 001, show interface status, you see these two columns here, right? That's duplex setting, that's the speed setting. Now you see A-full, A-1000. What does that mean? Well, A-full and A-1000 basically means that they were both set by the auto negotiation process. The auto negotiation did the job of this of setting those duplex and speed settings. Now, what we've got to remember here is, sorry, that was supposed to say A speed. Sorry, a full duplex, A full. That was supposed to say A-full there. A-full would have meant that full duplex setting was set by auto negotiation. A-1000 means the setting was set by auto negotiation. Okay, auto. If you just see auto like here, that means that this auto negotiation process will only occur when the link is working. Now let's talk about Auto MDX, Automatic Medium Dependent Interface Crossover. What a mouthful, eh? Well, Auto MDX, very important thing. Now, the best way I think I can explain it is that, let's say you got two switches. In normal circumstances, what would you do to connect them together? It's not a trick question, by the way. So just have a think. What do you do to connect them together? Just have a think. So what you would do is, you'd connect a console. You'd connect a crossover cable, not console cable, crossover cable, a crossover cable to connect both sides with both switches together. That's what you'd use, because the pairs cross over, and that enables the connection to work. Now, if you used a straight through cable, it would not work. However, if you have Auto MDX, it will. Why? Because Auto MDX is very clever. It swaps the pairs and in the electronics of the interface to make the connection work. It's very, very clever. It's quite an amazing feature. Now, okay, you have to enable this though, and you'd use MDX Auto to enable Auto MDX. No MDX Auto, that will disable Auto MDX. So it's quite a cool thing. Okay, it detects that, hey, I think you used a straight through cable. But what I can do, I'll swap the pairs in the interface electronics, and I'll still make this work for you. So it's really, really cool. Here's an example here. You got EDI switch 003. You got interface. You got gigabit Ethernet interface 1016. Now, on this interface, look, we do show interfaces 1016 status here. What you be seeing? Well, we can see this interface is connected. Okay, in VLAN 1. Now, that's great. If you wanted to turn off Auto MDX, we'll do no MDX Auto here. So we go into interface configuration mode for gigabit Ethernet 1016, no MDX Auto. Now, that's changed the state to down. Control Z, verify this now, show interfaces gigabit 1016 status. Now we can see this is not connect status. So in the not connect status, we've turned off Auto MDX there. Now, section 4 is management of switch interface configuration. So in this example here, you can see you got the Edinburgh switch 003. Now we want to set a description for the interface, which basically tells us what the interface is about. So in this case, configure terminal, interface gigabit Ethernet 101, description, link to EDI PC 005, Catherine's PC using auto negotiation. Okay, so we've done that here. Now what's happened? Link to EDI PC 005, KA and open bracket. What? Wait, what? What's that all about? Well, it turns out if you use show interfaces, insert the interface ID status, you may not see the full description. If it's quite a long lengthy description, like in this case, this is a long description. It identifies the PC, then the user, and it says he's using auto negotiation. It's quite long. It's quite a long description that that in itself is 1, 2, 3, 4. Then you got space there, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Maybe 40 characters there. But thing is, it's quite a long description. You might not see it if you do show interfaces gig 101 status. So if you want to see the full description, show interfaces gig 101. Just show interfaces, insert the interface ID. That'll give you more verbose output. Okay, you see here we just get this has been omitted. There's lines. This is not the full output as well. It's been omitted for brevity here, but you can see there's much more description even in that than what you're getting here. So if you want to see the full description, show interfaces, insert the interface ID, you will definitely see the full description. You may not see it with show interfaces, inserting interface ID, status. So just something important to keep in mind here. And these red lines here just basically highlight this. Show interfaces, insert interface ID may not give you the full description. In this case, it doesn't. Sometimes it might do, sometimes it might not. It depends how long that description is. But in showing interfaces, insert the interface ID gives you a verbose output which includes the full description for the interface. Example here is of when you do get the full output here, show interface gig 103 status. You can see the full description here, but it's not every time. Like in here, there's a longer description. We didn't see the full output with show interfaces, insert interface ID, status. We had to do show interfaces, insert interface ID, no status. Just show interfaces, insert interface ID. We see the full description here. Link to EDI PC005, Catherine's PC in brackets using auto negotiation. Now, just some more commands to know about. Shutdown, that disables interface. No shutdown, enables an interface. Okay. No speed, that will revert the speed setting to the default. And the no duplex command will revert the interface setting to the default duplex setting. Now, last section, analyzing switch interface status and statistics. So what we're going to be talking about: interface status codes, duplex mismatch problems, common layer 1 problems on working interfaces. So the interface status codes, right? Show interfaces and show interfaces description. These commands show line status and the protocol status. They show the line status and the protocol status. So here you see the protocol status. That's the line status there. Fast Ethernet 002 is administratively down. The line protocol status here, line protocol is down. Here we got the line status, up, admin down, up, admin down, admin down, admin down, admin down. Protocol status, up, down, 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 down. So line status and the protocol status. That's great. Okay, we're getting them. This is called two code status, right? Now, that's all well and good. Okay, and this is just some more. This is a description of what each of these mean. So if you have line status of administratively down, protocol status of down, and an interface status of disabled, that normally means common root cause is the interface has been shut down via shutdown command. So normally an administrator has shut that interface down, is disabled that interface, or she has disabled that interface. So line status of down, protocol status down, interface status not connect. So this can be many reasons. This is probably the interface status that has so much different root causes. It could be there's not a cable connected, a faulty cable, wrong pin out, speed mismatch, or there's a fault with the neighboring device, like it's powered off, or for example. So if you see down, down, not connect, that can have many causes. Up, down, not connect normally means an issue with your layer 2 config. Down, down, error disabled. This normally means that the port as security has disabled that local interface. Port security is kicked in and it's done that proactive job of disabling that interface. For example, you might have had an unauthorized user trying to connect a device into that interface, and the switch doesn't recognize the MAC address, and it's like, hey, I don't recognize the MAC address, hiya, and it doesn't do a karate chop, it disables the local interface. So it that interface is disabled. Okay, it's taking that proactive action, being a bit like a security guard, like, hey, I don't recognize that MAC address, shut that interface. It doesn't shut the interface down, it error disables the interface so it can't be used. So finally, if you see up, line status protocol, line status up, protocol status up, interface status is connected. So that means the interface is working. Yay! But we're not necessarily off the hook, and I'll tell you why. But firstly, I want to talk about single code status. So if you show interfaces status, this means this is just a single word, single column to instead of having two columns for line status, protocol status, you have a single code interface Sorry, not dingle code interface status. My bad there. Sorry, another error by me in making the slideshow. But that is a single column there to identify the interface status. But it's not like the other one here. You get this is probably superior because it's giving you more output, more specific information here. This one doesn't, but just it's good to know the difference between using these commands. Show interface description will give you line and protocol status. If you just use show interface status, it won't. Now, duplex mismatch issues, I wanted to talk about this because, for example, you have up connected state. That does not necessarily mean we're off the hook, and the reason is because there's problems like duplex mismatches, and duplex mismatches are not easy to detect, and that's why you got this poor engineer here, and he's trying to catch a duplex mismatch issue. All right, it's just just a little caricature, but I thought it would maybe help just to illustrate the problem. So this is a tricky spot. So speed mismatches result in failed links, but not in duplex mismatches. So duplex mismatches can happen on a link where an endpoint is using auto negotiation and the other isn't. Like in this example here, you got London switch 001 here, you got London switch 02 here. Now, this switch is using auto negotiation, this one doesn't. So the London switch is doing its thing and it's thinking, okay, I think it's using 100 meg per second, and 100 meg per second means half duplex. Okay, it's done that. However, the problem is now we've actually got a duplex mismatch now. We've got a duplex mismatch has been created, and that's not good if we've got duplex mismatch, because you've got a duplex mismatch now. It's actually using full duplex here. This is chosen half duplex. There's a problem. So the speed duplex mismatches result in failed links, but duplex mismatches don't, and that's what makes them harder to catch. And the last thing I want to talk about is interface counters. Interface counters can give you information about several kind of issues, and these are just some of them, but it's very important. It's one of the key topics for this for verification and configuration of switch interfaces. So this is one of the key things that I want you to take away from this lesson is runts, for example. Now, runts mean frames that didn't meet the minimum size requirements, which is 64 bytes. If you remember, for a frame, the frame format is that the data and the padding is anywhere from 64 to 1500, approximately 1500. So that specific number is 1518 bytes. So the frame, that is your data and padding size. Okay, that's the size. Yeah, minimum, maximum. So if it didn't even meet the minimum, then it's called a runt. If it exceeded that and the maximum, it's that 1518 is referred to as a giant. Input errors, that's a total of many counters, including runts and giants. CRC means receive frames that didn't pass the cyclic redundancy check math. Frame means receive frames with an illegal format. And output errors is basically the total number of problematic frames that the interfaces try to transmit. And the collisions are just count of all collisions that are occurring when the interface is transmitting frame. And then lastly, late collisions is a subset of all the collisions that happen after the transmission of the 64th byte of the frame. So if normally if you have you'd have a collision in the first 64 bytes. If it happens after, it's referred to as a late collision. So these are some of the problems. Okay, and that brings us to the end of this this lesson. So thank you guys so much for watching. There will be a test coming out at some point, so please bear with me for the test. But I hope you've taken away some good information from this lesson and found it useful. So thank you so much for watching. Please like, share, and subscribe. That really helps me out. Thank you so much. Take care. Goodbye.